Chapter 7 is similar polygons. Similar polygons. Remember, polygon means many angles. Similar is same shape, not necessarily the same size. We just finished with congruency. The things that give triangles their shape are the angles. The things that give them size is the sides. In congruency, the sides, corresponding sides were all equal, and the corresponding angles were all equal. And the corresponding angles being equal made them the same shape. The corresponding sides being equal made them the same size. In similar polygons, the angles are equal, corresponding angles are equal, which gives them the same shape, but they're not necessarily the same size. One is larger than the other, one is smaller than the other. If we think about going from smaller to larger, we would say that we uh, scaled up, we enlarged, we dilated by a certain factor. That factor by which we enlarged, we call a scale factor. So we could say it scaled up by a factor of this, or scaled down by a factor of that, or we could say it dilated by a factor of so and so. So again, when we talk about similarity, we're talking about same shape, but not necessarily same size. We're going to begin this chapter with the basics of ratio and proportion. We'll get into the properties of proportions, and then we'll get into, in Unit 3, similar polygons. Then we're going to learn how to prove that polygons are similar by several different methods. We'll have a postulate to prove that triangles are similar and some theorems to prove that triangles are similar, just as we had some postulates and theorems to prove that triangles were congruent. We're going to look at proportional length. It's a special situation that happens uh, based on the concept of similarity and proportionality. And then we've got the odd answers in the review. So we're going to begin with Unit 7.1, ratio and proportion. Ratio is on page 51 and 2 of the Algebra 1 text, and then proportions are on page 55 and 56 of the Algebra 1 text, if you'd like to make that connection. We said that a ratio is a comparison of two items. A comparison of two items. You can say, well, what's the ratio of boys to girls in the classroom? It says a room has 6 boys and 8 girls. Now, it says, what is the ratio of boys to girls? On page 51 of the algebra text, we had these rules about ratios. We said a ratio has to be in the order of whatever it said first goes first. So if it says boys to girls, then we would put boys first or boys on top. So we would put boys on top if we write it as a fraction of girls on bottom, since it said boys first, girls second. Or if we use our colon, we would have 6 to 8. Or if we use the TO, we would have 6 to 8. So whatever it said first goes first. We also said that you cannot have a decimal in a ratio. A ratio has to be whole number to whole number. So if there were decimals, we would have to shift our decimal to fix that. And all ratios must be reduced by dividing each member of the ratio by the greatest common factor. So if you were to divide both the 6 and the 8 by 2, you would get 3/4. And so the ratio of boys to girls in simplest form is 3 to 4. Example 2 is an extended ratio. It's an extended ratio. And if you're going to simplify an extended ratio, you need to divide by something that goes into all three. It can't just go into two of them. So the greatest common factor of 10, 20, and 30 is 10. And so it would simplify to 1 to 2 to 1 to 2 to 3, excuse me, if you divide each one by 10. Okay? So a ratio is a comparison of two items. Whatever it's said first goes first. You cannot have a decimal decimal in a ratio, and each ratio must be simplified by dividing each member of the ratio by their greatest common factor. Okay? And now we come to proportions. We defined a proportion in Algebra 1 as two comparisons of the same two items. In other words, a proportion is two ratios. And it's two ratios with an equal sign in the middle. And so the official definition of a proportion is an equation stating that two ratios are equal. An equation stating that two ratios are equal. Now, I define it this way because this is how you're going to use it in a word problem setting. You're going to see two comparisons, and then you're going to set up a proportion. Notice in this particular example, it says if 4 people can eat 8 hamburgers. Now, that's the first comparison they give you, people to hamburgers. And then it says, then how many hamburgers can 12 people eat? This second comparison is also people to hamburgers. So we're going to have people to hamburgers. And I did in the Algebra 1 text to kind of make this a little more plain as we said, okay, we have a statement that they gave us. That's our first comparison. So we called the first comparison the statement ratio in the Algebra 1 text. We said then they're going to ask us a question, and there should have been a question mark there. And so the second comparison here is the question. So we have a statement ratio and we have a question ratio. And in Algebra 1, we said we always fill out the question first. So the question was how many hamburgers, so we call that H, can 12 people eat? And then we go back to the statement. The statement, we need hamburgers on top because we have hamburgers. Oh, I wrote that upside down, didn't I? Excuse me. In the question, how many people was 12, sorry. In the question, how many hamburgers, we don't know H. Since the question is people hamburgers, we make the statement be people hamburgers. So people was 4, hamburgers was 8, and we get a proportion. 4 over 8 equal 12 over H. Now we could reduce the 4H there. Okay. So we're going to have the 4, 8, 12, H. If you wanted to reduce the 4H to 1/2, you can reduce like that. Or you can just leave it 4/8 and then cross multiply. So H times 4 is 4H is equal to 8 times 12 is 96. We call this the product of the means as we go to the left and the product of the extremes as you go to the right. Now we're going to undo multiplication by division, and we would get H is equal to 14. Sorry, 24. Any questions on that? Sorry about the little blunders there. So a proportion is two comparisons of the same two items. They're going to give you a statement. They're going to give you a fact where you know both of the elements of the ratio here. And then they're going to have a question, and in that one, there's going to be one of them you don't know. And then you set up your proportion, cross multiply, and solve. Okay? This little rule right here is actually Rule 4 on page 52 of the Algebra 1 text. To assign variables to things in a ratio, you multiply each member of the ratio by x and have only one name. So we want to remember that little rule as we do the daily work here. So let's move on into the daily work. Now, we're needing to know the properties of a parallelogram. We know that this is a parallelogram because both pairs of opposite sides are equal. That's given information 14, 14, 38, 38. We want the ratio of AB to AF. AB to AF. AB is 14. AF is 38. So we get 14 to 38. We have to reduce by dividing by the greatest common factor. The greatest common factor would be 2. So reduce, that would be 7 to 19. Any questions on number 1? We know that since both pairs of opposite sides are equal, it's a parallelogram. And since it's a parallelogram, we then could conclude that both pairs of opposite angles are equal. Number 4. Number 4 wants the ratio of angle B to angle G to angle F. So angle B is 48 degrees to angle G. And we don't need the degrees because remember a ratio is whole number to whole number. So we don't need units of measure. 48 to angle G, which is 132, to angle F, which is 48. We would divide by the greatest common factor, which would be 12. 12 will go into 48, 4. 12 will go into 132, 11. 12 will go into 48, 4. And so we get 4 to 11 to 4. Any questions on that? This next set of questions, if you need a really good reference, on page 52 of the Algebra 1 text, we have the rules for the sum of the angles of a triangle is 180. We have complementary angles, or two angles whose measures have the sum of 90. We have supplementary angles, or two angles whose measures have the sum of 180. We learned these three rules as far as complementary, supplementary, and the sum of the angles of a triangle. In this geometry text also, we have problems that look like these problems as far as examples and how to set it up on page 52 of the Algebra 1 text. So we know the facts from the geometry book. We see the drill in setting these up and solving in the Algebra 1 text. We're going to do number 5 here. I'm going to present this the way that I would present it in Algebra 1 class. I write characters in word sentences as we solve. So what I would have my students do in Algebra 1 is we would say, okay, if you look at page 40 in the Algebra 1 text, it's we're going to first of all read and understand the story, the angles of a triangle and the ratio 1 to 2 to 3, find the measures of each angle. We'll identify the character or characters of the story. Again, I'm quoting page 40 of the Algebra 1 text. To find our characters, we find them in word sentences. Word sentences could be a comparison between two characters, like David caught 6 more than twice as many fish as Joy, or the length of a rectangle is 4 more than twice its width, those kind of things. B, formula words like perimeter, area, volume, circumference, or the sum of the angles of a triangle is 180, or complementary, supplementary, or any other formula word that has an equation built into it. Well, angles of a triangle has a built-in formula by memory that their sum is 180 degrees, which means that first angle plus second angle plus third angle is equal to 180 degrees. Three angles have the sum of 180. So we would put angles of triangle on our word sentence line, and we would drop down below it and write the equation: first angle plus second angle plus third angle equal 180. And the characters of the story then would be the missing pieces of my equation that I left there, which would be the three angles of the triangle. And we'll call them angle sub 1, angle sub 2, and angle sub 3. And we can't call them x, y, z because you can only have one unknown in an equation. So these need to be named in terms of the same variable. On page 42 of the algebra text, it says, to be able to do the order of operations, you can only have one variable or one name. If you have more than one, you must name one in terms of the other and use substitution, or use special rules to name each of them in terms of the same variable. Now, special rules, there's four of those. They are consecutive integers, consecutive even integers, consecutive odd integers, and things in a ratio. To assign variables to consecutive integers, again, this is on page 42 of the algebra text, you assign the variables as x, x plus 1, x plus 2, because the gap between them is 1. Consecutive evens and odds are 2 apart, like 3, 5, 7, they're 2 apart. 2, 4, 6 are 2 apart. So when you assign variables to consecutive evens or consecutive odds, you call the first one x, the next one x plus 2, the next one x plus 4, etc. To assign variables to things in a ratio, that little rule is on page 52 of the algebra text, and it was on the in the notes here for this lesson, page 159. Says to assign variables to things in a ratio, you multiply each member of the ratio by x and have only one name. So what happens here is we say, well, I can't call them x, y, and z unless I have more equations, or I have to have special rules. So I got to have more word sentences, or I got to have a special rule. We know what our special rules are, and so when we identify that, we say, hey, ratio of blah, 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 that's a special rule. So that means I'm going to use that special rule to assign my variables to my characters, and I will be able to give them all the same name x, because we know to assign variables to things in a ratio, you multiply each member of the ratio by x and have only one name. So we're going to have 1 times x, 2 times x, whoops, it's 2x for the second one, and then 3 times x for the third one. So we multiplied each member of the ratio, the 1, 2, and 3, by x, and we've got x, 2x, and 3x for the angles. We can now plug those in. First angle x plus second angle 2x plus third angle 3x equal 180. And then we solve using the order of operations horseshoe on page 33 of the algebra text. So we're going to see if there's anything we can do to simplify in the order. Please excuse my adherent Sally. Looking for distributive and combining like terms. We're going to combine like terms. 3 of those plus 2 of those plus understood 1 of those makes 6 of those little x's. Now we're going to undo multiplication by division, and we'll get x equal 30. Now, what we said to do, this is quoting page 40 again on word problems, is we're always going to read the question again, find out what it asks for. It says find the measure of the angles. We need the angles. We haven't done that. So we're going to have to take that 30 and plug it back in. So this first angle x is 30 degrees. The next angle is 2 times 30 degrees, which would be 60 degrees. And the next angle is 3 times the 30 degrees, which is 90 degrees. Any questions on number 5? Okay. Let's just look at number 7. Number 7, it says 2 supplementary angles. Now, we quickly identify that as a formula word. We're supposed to know the definition, and that definition is that supplementary angles. Remember how we did that, knowing the difference in complementary and supplementary. Supplementary is S, which is kind of the shape of an 8. Supplementary angles have the sum of 180. Now, it's 2 angles whose measures have the sum of 180. 2 angles whose measures have the sum of 180. So the characters of my story are angle sub 1 and angle sub 2. And again, I cannot call them x and y unless I have more equations. So I need more equations, or I need a special rule. And we keep reading, and it says they're in the ratio of 1 to 5. And so we have the special rule of things in a ratio. To assign variables to things in a ratio, you multiply each member of the ratio by x and have only one name. So we're going to have 1 times x is x, and 5 times x is 5x. And so the variables assigned to these angles are x and 5x. They both have an x, so there's only one name. So we're going to plug them in and solve using the order of operations. First thing we're going to do is combine like terms. 5 of those plus understood 1 of those is 6 of those little x's is equal to 180 degrees. Undo multiplication by division. We get x is equal to 30 degrees. Read the question again. Find the measure of the angles. So we plug it in. So the first angle x is that 30 degrees. The second angle is 5 times the 30 degrees, which is 150 degrees. Any questions on number 7? Okay. On number 9, don't forget how to change this into a mixed numeral. You're going to have 4 times 5 is 20 plus 1 is 21 over 5. So you're going to have x over 21 over 5 is equal to 2 times 4 is 8 plus 1 is 9 over 4. 6 times 2 is 13 plus 1 is 14 over 2. If we use the fractions, here's what we would see. We would get 14. That's a 13. That's interesting. 2 times 6 is 12 plus 1 is 13 over 2. That's better, isn't it? So we get 13 over 2x is equal to, when you multiply 21 times 9, you get 189 over 5 times 4 is 20. And then remember on page 25 of the Algebra 1 text, we said you undo multiplication by division, or, and I would say or in Algebra 1, and we would have to say multiply by the reciprocal, right? We never say undo multiplication by division again. We used to say you undo addition by subtraction, which is still good. You undo subtraction by addition, which is still good. We used to say you undo multiplication by division, and we tried to break you from that and say you undo multiplication by division or multiply by the reciprocal. So when you get to this situation, you know what to do, and you're going to get x equal, and I'm going to let you finish that, okay? So we changed the mixed numerals to improper fractions. We cross multiplied. When you undo multiplication by division, instead of thinking division, we're thinking multiply by the reciprocal. Okay? All right, let's look at number 12. It says in a class of 28 people, 16 were boys. We would have called that the statement ratio because they gave us both pieces of it. And then it says at the same rate, how many boys would be in a class of 42 people? And so they've asked us a question, and so we have a question ratio. So we have two comparisons. One's a statement, one's a question. And here's how we lined it up in algebra class. We said we have a statement ratio. Whoops. Get it like I want it. I'm sorry. And then we had a question ratio. And we always want to make the entire proportion say what the question says. The question is boys to people. So we're going to put our question in the form that the question ratio had it, boys, people. Now, if the question is boys, people, we have to make the statement be boys, people also. Sometimes it'll give you boys and girls in the statement. You have to add them up to get people. Remember that? Kind of deals with that on page 56 of the Algebra 1 text. So we fill in the question ratio first. The question is how many boys we don't know. We'll go to 42 people we do know. And then we go to the statement, and the statement is how many boys, 16, to people, 28, and so we have a proportion. Now you can reduce the 16 and 28 if you want, or you just go ahead and multiply. So we're going to have 42 times 16 would be 420, 240, 660, 672. I might want to check that out. I believe that's 672 is equal to 28 times 2 times b, which is 28b. Let's double check 16 times 42 here on the calculator, which is fine to use. 16 times 42 is 672. That worked out good. And now we're going to undo multiplication by division. So we divide by 28. We'll get the number of boys equal. We're just going to go back to the calculator there. 672 divided by 28. Divide 28, 24. Any questions on number 12? Okay. We'll let you do some of these. You need practice with all of that. Let's just look at number 18. Percent means how many out of 100. Percent means cents or pennies. A penny is 1/100th of a dollar. So how many out of 100, or how many hundreds? We're going to set up a proportion and solve. It says if a bag of green, okay, if a bag contains 6 green balls and 18 red balls, then what percent of the balls are green? Now, there's several ways that we could solve this percentage. We're going to look at 3 ways. First of all, here's using the proportion method. What we're going to do is put green over total is equal to percent over 100. Percent means hundreds. So we can take the number of greens over the total. That would kind of give us the fraction. And we want to make that equal to so many hundredths. And by making our fraction equal to hundredths, we've turned our fraction into a percentage. So we're going to take the number of greens, 6, over the total 24. You understand how we got the 24? There's 6 green, 18 red, 24 total. We had to add those up. If we want the percentage that are green, we need green over total is equal to x over 100. We're solving for the percentage. That's one method. Another method is just converting the fraction to a percent. This method would be using a proportion. We could just say, well, the number of greens is 6/24, and we're just going to make a percent out of that. And then the third method is on page 63 of the Algebra 1 text, and that's using the equation part is equal to percent times whole. Now, the interesting thing is, as we progress through the years of math teaching, when I first started teaching, we had the different exit level tests or different tests that we had to take in school, like the TABS and the TEAMS and the TAS and the TACS and now the end of course and all those kind of things that are coming up. In the early days, it seemed like things leaned this direction, and then they started leaning this direction, and now they're leaning more of an algebraic equation concept. It's important, I think, to know all of the ways to change, to find percentages and understand how they interconnect. And so we want you to see this connection. If we write this equation, we would have part 6, the part that's green, equal percent x times the whole 24. Do you see the similarities? We've got the part and whole involved in all of it. We're trying to change in the first thing 6/24 into so many hundredths because hundredths is a percentage. In the second one, we're taking 6/24 and we're going to change it to a decimal by dividing and then to a percent by shifting our decimal. In the third block, we're writing an algebraic equation, part equal percent times whole, and after one move, it looks like the other thing. So let's watch as we progress, okay? As I solve the proportion, I would cross multiply, and I would have 6 times 100 is 600, is equal to 24 times x, which is 24x. I then would undo multiplication by division. If we have x equals 600, divide 24. Do you see the 6/24 there? Only at 624. Okay, let's kind of leave that hanging. So we can kind of visualize there. Six 24ths times 100. And here we see 6/24. And in a minute, we're going to shift the decimal, which is times 100. And right here in the algebraic one, we're going to undo multiplication by division. And there's your 6/24 again. So now, no matter how we solve it, we're going to come back to the same multiplying and dividing before it's all done, see? So what we would do here then is we would take the 600 divided by 24. Let's do that on the calculator. 600 divided by 24. Which is 25%. Now, how do I know it's 25%? Because what I found was the number of hundreds, you see. In the proportion, we found out how many hundreds, and that is the percent. Now, if we look in complete the second one where we're turning a fraction to a percent, what you do is you take the numerator 6 divided by the denominator 24. So we would do 6 divide 24, and we would get 0.25. So when you actually do the division, you get 0.25. So what we have is fraction to decimal, and then to change the decimal to a percent, you move the decimal 2 places to the right and add the percent sign, and we have the same result we do by using a proportion. When we used the proportion and found hundredths, the number of hundredths is the percent, and we didn't need to shift the decimal. If we solve using the percentage equation from the Algebra 1 text, part equal percent times whole, after the first little move where we undo multiplication by division, we're right back to here, which means you need to divide the 6 by 24. When you divide 6 by 24, you're going to get 0.25. So when you solve in the algebraic equation, you get the percentage as a decimal, and then you have to shift that decimal 2 places and add the percent sign, and so you would get 25%. Any questions on number 18? Okay.